My name is Mr. Vere, Director of C.A.S.T. C.A.S.T is Control and Automation Solutions Technology. We're all about Siemens automation, design, installation, commissioning, PLC debugging, and training. My details or contact details that you will see coming up shortly on the screen. So we're here to train for all your automation solutions in systems designing, installation, consultancy, debugging, and PLC training. Right where you are, you might think, you might be confused about automation, having challenges here and there, what this automation is all about. Today, I'm here to run you through a design that I did for electric motor stator temperature visualization on the HMI. So I'll run you through the program in TIA, which is version 13, Totally Integrated Automation Portal version 13. So we wait for the program to start up. Yes. We're going to start in our project folder, motor bearing and stator temperature control. We open the program. Right. We then go to project view. We click project view. That's where we can navigate to the various aspects of the project that we need to access. We go to PLC 1 CPU 315, 2 PNDP, meaning that the version of our CPU in the S7300 family of CPUs, this is 315. And then meaning 2 Profinet interface protocol ports, which is a distributive protocol. So we open our project. We go to program blocks. This is where we have the main block. So for us to simulate and get a feel of it, I'll go through the design of the program. In this block, which is a function call 1, this is where we have the design of the program. Right, in my network 3, I've got motor 1 winding temperature. In the previous program that I showed you for the steam valve PID control, we've got scaling blocks. The reason we have this scaling block is to convert our standard engineering value 27648 to a form that will present our temperature, our pressure, our water level, because in some instances we need bars, we need degrees, we need liters, we need flow rate, cubic meters per second, per minute, whichever case may be. So the scaling block will take what you are getting from the analog input card and scale it to a form that is presentable on an HMI. So this is the scaling block for motor 1 winding temperature, which is our stator temperature. And network 4, here we've got a comparator that will give us a measurement set against a set point. Our comparator is to give us our set point against a measured process variable. So if I'm going to set my stator alarm for the temperature to be at 95 degrees, the set point should be 95 degrees, and then my process variable should be coming from 0 to 95. And then if we reach 95, our motor height stator temperature alarm will indicate on the HMI. So we need to download this program so that we can simulate. So I'm going to start my PLC simulator here, my S7 PLC simulator, so that we can simulate this program. Good. We've got our PLC simulator. I have to download this project. Let me adjust it up. All right. Now I have to highlight my program blocks. Then go to download here, download the device. Waiting for my program to respond. Right. After compilation, I can then download. I download my program. Now, we wouldn't want to have any errors or any warnings. Rather, this program will tell you whether it was loaded successfully. The main organizational block 1 was loaded successfully. Block FC1 was loaded successfully. The analog data DB1 was loaded successfully, and the scaling analog scaling block, which is the block that is currently opened now, was also successfully loaded. Now in this regard, I take my PLC and switch it to run mode. I shouldn't have any errors. This red indicator should be off. Yes, I don't have any errors. If I do not have any errors, I go to online mode. If I go to online mode, I should see some green dots here to show that all my blocks that I've downloaded to the CPU are in run mode and ready to monitor. Yes, this is wonderful. I hope you're getting this. I'm taking you stage by stage, bit by bit on every aspect of the project. I'll put my project in monitoring mode. I click monitoring. Then when these lines are indicated green as they have now, it means I'm in monitoring mode. My program is in run mode. Now, like I said, in this scaling block, we have got, this is our minimum set point for the stator temperature, which is starting from 0 degrees. This is our maximum set point for stator temperature, which is 100 degrees. Right. I bring up the simulator. You see here where it's written temperature on motor 2. This is a peripheral input word 258. This is the same input word that I have to insert on my PLC when I want to simulate a specific input for an analog instrument. I insert my maximum value for the standardized engineering value. All right. Now watch what happens when I drag my slider. You should see this 0 has to change. You see, this is what I'm talking about. So as I slide my slider 65 degrees, 70 degrees, you see my temperature is increasing. And my standard engineering value of 27648, the one I mentioned before, this is what is being scaled to a form that I will see on my HMI screen. Now, so where your motors are located and where your CPU and HMI are located might be two different locations. You want a system which is called a decentralized system, where you have a communications interface, which is your Profibus or your Profinet. So I'll show you the networking just after I'm done with simulating the HMI. Now we go to the HMI, which is a TP900 comfort panel that I have to take to online mode. Then start the simulation for my HMI. So the same values you've seen in my program are the same values you see on my HMI. if everything has been done properly. Good. I have my motor temperature. This is my semantic touch panel. I put it into full screen mode. I bring up my simulator. Now, motor 8 is the one we're going to test first. The green indication shows that my temperature is normal, no alarms. So the moment you start our motor, it's running. Of course, the current will be flowing in the stator windings. The temperature will increase with the load. So here I'm digging up. I want 256. Right. You see, watch on my screen. Now I have 11 degrees as I'm sliding here on my simulator. The purpose of this simulator is to test your program before you load it in the actual CPU of the PLC in whatever plant that you've designed, so that you know that every safety feature in your program is working properly. So as I approach 90 degrees up to 95, that's where my indication will show. You see, my stator temperature indication is showing that I've reached the maximum set point for my temperature for the stator. You see it's flashing. So this will warn the operator to go and check or to stop the pump or the motor, whatever it is driving. You stop, you switch off, and you check either the motor is overloaded, or maybe it might be instrument malfunction. So that's the purpose of the touch screen. You can control, you can monitor depending on the design of your program. In some instances, you'd want to see the drive end bearing temperature, the non-drive end bearing temperature, all that you can do in the program. Once you can design the stator temperature, you can do the same for the bearings. So this is the HMI. We do the same for the second motor. Our temperature is rising, our temperatures are rising. You see, now it's flashing. Here I need the standard engineering value changed as well, 27648. Right, it's done. I do the same for motor C. Peripheral input word 260, and I also change my standard engineering value. Okay, 27648. I also test my program as well there. You see motor C, 32 degrees, 33 degrees, 44 degrees, 62, 70 degrees. My stator temperature is rising up to 95. I should get indication again. You see, this is all designed within the program like I showed before. I have to change here again my standard engineering value 2648. Enter. That's my maximum value. Now I have to go again. Two 56, 258, 260. Okay. See my motor D temperature, stator temperature is increasing. You see now 79, 83, 91, 95. You see we all have alarms again. So I want to take you through the communications interface. In Siemens, we've got Profibus,
We've got Profinet, we've got point-to-point, RS485 to RS422, 232, you name it. So we go to device and networks. In our TIA, we want to view our networking. You see, my PLC and HMI are connected via a Profinet interface Ethernet protocol. We can go to network topology, check out this. Network view. You see, this is my networking. My HMI, I can show the address labels. IP address for the PLC is 192.168.0.1, and then the difference is the last digit with from my HMI address. There's a 2 at the end. You see, the minimum and maximum set points are within this analog data that I'm going to open now. You can visualize the processes as they are going as you monitor your data block. Let me enlarge. You see, here is the comment list. Motor A winding temperature high set, motor A winding temperature low set, motor A temperature scaled data output. This is where we change. Let me bring up my simulate. You see, as I drag, look at this digit here, it changes. You see. You see. So you would want to view your CPU or your PLC rather. In TIA, you can view whatever you want to view when you go to your device and networks. You go to device view, go to PLC 1. You can enlarge as well. Go maybe to 200. Now you can actually view your CPU and your analog input module. You can actually see that here we've got temperature. Let me increase again to 250. All right. Temperature for motor 1 there, temperature for motor 2. So the moment you move your mouse, it will show you that the temperature for motor 1 is at analog input 256. Motor 2 temperature, analog input 258, and then temperature for motor 3 is at analog input 260. So on and so forth. You can actually see here, this is an analog input with 0 to 20 or 4 to 20 milliamp ports. Here you can open and see the properties. If your analog input was a voltage source, you could change that within your program. You see, I'm on channel 1 here. I can check here. You see, measurement type. It's a 4-wire measuring transducer for current. You see, 4 to 20 milliamps. I can change this, say, into a voltage source, 2-wire transmitter.
an RTD resistance temperature device, PT100, 2-wire, 3-wire, 4-wire, or a thermocouple, you see. So that's the basics for programming motor bearing stator temperature in TIA version 13. For any information you might need, trainings and automation, C.A.S.T is there for you. Control and Automated Solutions Technology for all your automation systems designing, installation, consultancy, and debugging and PLC trainings. I'm Mr. Vere, Director of C.A.S.T. You can visit me on my Facebook, on my WhatsApp, or you can email me, or you can call me for any automation related tasks. Thank you.